everyone. Thank you for joining us today for Solving for the Unknown with Elastic on Azure, Fraud, Compliance, and Science. Before we introduce our speaker, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speaker. We want the reactors to be a place everyone feels welcome. Please ask questions using the live YouTube chat. In the chat, we'll also be sharing out some links to the Reactor Meetup page, as well as other links that go along with today's content. Today's session will be added to our Reactor YouTube channel in the next 24 to 48 hours. And finally, near the end, I will be sharing a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. And I am now going to pass it over to our speaker today, Dimitri.
Thank you very much, and thank you for having us on this session today. So we're going to talk today about our imperfect view of the world in terms of what we have in the digital realm and how we can solve for complex data problems using search technology, Elasticsearch. First of all, a little introduction of myself. I'm Dimitri Max. I'm with the solutions architecture team in EMEA on taking care of our partners, partner ecosystem, which are hyperscalers, but also partners outside of hyperscaler business. And I've been with Elastic for around about 8 years. And now today, I'm going to give you a little bit of introduction what you probably already know about Elastic, just to make sure that everybody is aware about that. And the second part will be about the things which you probably don't know about in terms of what a search engine can you help with. Be patient with me. I will start with high level, really talking you through what type of challenges you can solve in real life. And for those who are hungry for technical details, please be a bit patient. I will be covering some of them a bit later in the second part of the presentation. There will be 1 or 2 demos depending on timing, but I have some demos as well to give you an idea how you can get started. So let me then first cover a bit about what you probably already know about Elastic or Elasticsearch or Elasticstack. We've been on the market for more than 10 years, and operating at the beginning from open source space. And Elasticsearch was born as a search engine actually for recipe search, right, or whatever textual documentations you have. But over the time, and given that we have open source distribution model, people have started to invent new solutions based on the technology. And today we are quite proud to say that we bring search experience to whatever data we have. It doesn't matter if you deal with bugs, errors, threads, or documents like Word documents, PDFs, and that kind of things. I think it's not bold to say that Elastic is probably the biggest search engine inside of firewalls. That was attested by Forbes. And there is also DB Engine's evaluation metrics, which kind of monitors what technologies are ranking top. So, and we are the top ranked search technology there. So we're talking about here mainstream technology. Over the time, as we established the notion of the Elastic Stack or ELK Stack, you've probably heard this abbreviation. It stands for Elasticsearch, Kibana, and Logstash. We have seen people using us in many different areas, and today we categorize these areas in three sections. It's enterprise search. Whenever you have searching for documents within a company, or you want the e-commerce search experience and on your website, observability for dev people, or security. These are the solutions we have based on the same Elastic Stack experience. And the Elastic Stack itself represents actually a big chunk of what's doable today. And we're going to spend today a lot within Elastic Stack itself, specifically with Elasticsearch and Kibana. And really quickly, just to keep, to make aware that same technology, you can use then, different solutions based on that, and basically address demands and needs of different personas with your organization. But that's all what I want to say to that. Now, in context of our partnership with Microsoft, we've been very active jointly to bring your all deployment options. Whenever you decide for Elastic on Azure, for instance, you have all options to deploy your way. You can use compute power, compute resources, and manage Elastic on your own, or that's probably the most preferable way for many people to go to managed service. So you have all that. So if you want, after this presentation, take it for a spin, just do it. There is a marketplace. For instance, a marketplace. There is a one-click deployment option where you can basically quickly spin up deployment and start using and experimenting. Okay, that's probably what you already heard when you've been touching on Elastic in your prior life. But today, again, my job is here to tell you things about some things you're probably not aware about. But there is in everything we do an intrinsic why, and I want to start with this why. Again, be patient. It's going to be here a bit of kind of high level and give you a bit of understanding what we try to solve. There are some business problems, some serious business problems. If you think about Panama Papers, for instance, right, when people kind of try to discover who is involved in illegal activities, it's one of them. Think about banks or insurance companies, federal agencies, for instance, or insurances are interested in to detect if the cash for crash scheme, when people claim for money. And that happens from time to time when folks claim and then change address slightly, right? So then companies are not able to detect that that's the same person actually behind this claim, and that way they can just make sure that they get a money refund, a much bigger money refund. Another problem people want to solve, or federal agencies want to solve, for instance, is police forces. Should we be careful when we stop a car, and to be careful with the driver and the passengers? There might be some history with these people, like carrying gun and that kind of things, and that's a question we need to solve. Or again, coming back to the banking environment, know your customer compliance. So understanding if customers are doing any illegal activities, for instance. So banks can be make responsible of these activities, and they need to understand what customers are doing. And these all are not easy problems to solve, data problems, right? But again, these verticals like insurance, banks, federal agencies, and companies, basically really who want to make out more sense out of data, are interested into this type of questions or similar questions. Ultimately, and at the end, what customers want really, or enterprises want really to know, is to get a visibility in all things happening within the organization itself, or when interacting with other parties like customers or partners, right? And here's a kind of real life example, a banking example, where the customer wants to understand if there are any fraud going on motivated by customers, or how we're doing with claims, or how we're doing with call center. All that might be all related to one person, right? So how we bring things together to get this visibility across all of these different data sources and data types. Again, the challenge here is, just to make clear what we're talking about, is that we see the world in an imperfect way, because the way how we judge the world today, right, using all the computer-related means we have, is based on basically digital information, but this is just a subset of the real world. And most of it is very, very unstructured. So how we deal with that? In addition, when you think about this data exists in, as I said, in many different places, but also in different formats. Like you have structural text information, you have unstructured, like think about insurance claims. There might be, some part of it is structure, and then there might be some additional information describing the reason for the claim. How do you deal with numeric temporal data, like geospatial data, for instance? Temporal and geospatial data, or binary information. All that needs to be bound to meaningful, in a meaningful way, so that you can have a good understanding. And here the concept is of, we're going to talk about is entities, right? So because everything in the real world is an entity, it's object. And with that object, you associate properties or activities or whatever I have, right? Like a person with having a name, doing some activities, transactions, bank account, and that kind of thing. So how we can make sure that we, bind that together and make it searchable. And that's exactly what I'm going to talk today about. Now, let me talk about some of the techniques, and most of these use cases I'm talking about is really kind of understanding what's the risk we have, right? So when we deal with things or people, are there any risks involved? Is there anything we need to be aware about? And there are many, two big ways, or two ways how you can deal with identifying entities, and that's in automated fashion and manual. I think manual is quite straightforward. Automated is where when you deal with unstructured data like Wikipedia or text messages or emails, right? One of the ways is to do that is actually named by extracting entities out of this information, like identifying people, identifying places, identifying things. And in a structured way, and that's something what I'm not going to cover today, is by ID chaining, basically, right? So you will need a way how you identify things, and there is a more sophisticated implementation will use something like adaptive ID chaining system approach. Now, a typical flow or typical components within a risk scoring stack is at some point you need to ingest the data. You need to get the sources and ingest the data, and within the ingest you will probably need to cleanse the data, because there is something probably some pieces of that which we don't need, or they are useless. You will need to enrich for sure. You will need to normalize. So that's something I will cover quickly. Linking, how you then to extract entities out of the information. At some point, you will need to do risk scoring, and then, of course, you will need to investigate. So we'll try to touch on all of these areas. Again, it's not a complete overview, because I think you can fill books about this topic. But I give you an idea, and again, referencing back to what's possible in Elasticsearch itself, right, or in Elasticstack. So let's start with simple building blocks, and that's something I'm kind of, when you think about the ingest phase of the data, you need to gather data and structure the data. There are some options you have in Elasticsearch itself. Obviously, you need to connect connectors or crawlers. That's something we have today as well. You need to extract the data. You need then to tokenize, normalize, and that kind of thing. So again, there are a lot of tools available within Elasticsearch itself. I'm not going to cover this because it's kind of I assume that when you need that, you can read the documentation, right? And it's pretty straightforward. I want to talk about things which are probably less obvious. Now, let us set the foundation first and really enter the search space and how Elastic structured in terms of query side of the house. And on the left side, you see a very simple query string searching for New York City or Big Apple, and that's basically it, right? So you have a default field, so nothing spectacular here. On the right side, you have an example for aggregation, and there are many different aggregations. I'm going to talk as one specific aggregation in today's session. And that's an important one, because you can basically combine just searching for keywords or putting filters with aggregations. And you can have not only one aggregation, but you can aggregate on many different things. Textual information you could aggregate on, numeric data, geospatial information, and you can do that in one query. That's important because that enables you to build very powerful applications. This is just an example from Revolut. I did a screenshot of my account here, where you combine KPIs, visualize that, and you bring all the search experience just looking for keyword search. That's simple as this, but it's an important one because when we investigate or build tooling on top of Elasticsearch, that's important to understand because it's quite powerful way to work with data. And another example, which we, one of the banking customers, using queries, search capability, but also aggregations to build powerful and interactive dashboards, which can go, just a keywords, or you can go deeper and click on KPIs or geospatial information and that kind of things, right? So this is all within the aggregation space and search queries. Now, another important aspect, again, here we're going to different data types, is temporal and geospatial information. And when you think about, let's imagine you do analysis of Airbnb listing, and I'm going to show you an example. One of the questions you might have, because you're looking from fraudulent perspective, like fraud perspective, how many anomalous listings are posted for New York City in the last month, right? So in this simple question, which is not as simple actually, there are multiple things involved. Like we need to aggregate how many, right, over certain criteria. We need to search for or filter, right, for specific things. We also need to understand that New York City is a geolocation. That means we need the capability to isolate the data set which is related to this space. And there is a temporal, like timestamp, like we're interested for last month, right? So this is not easy to do. And now with Elastic, we have this ability. So you have the ability to combine all these different queries for all the different data types in one query. That way that then you can enable a much sophisticated tooling, like for instance, Kibana, that's Kibana. So the visualization software we have on top of Elasticsearch. So that way you can then build powerful visualization, interact with your data, right? We're going to spend like in one or two demos a bit more time in Kibana. Now let me cover a very specific one very special aggregation type. And again, aggregations are, think about them as a group by, right? So you group over specific criteria, and there are many different aggregations in Elastic. For instance, you can aggregate over geo-bounds, like geo shapes, or you can aggregate over metrics, or you can aggregate over textual information. And I want to talk about significant terms specifically here because that helps to solve a couple of different problems. And you probably know, the screenshot. Actually, it's titled Predator, right? Heat Vision. So it comes from the Predator movie. When we think about significant terms aggregation, that works in the same way. So you have information in the picture or in your text, and then the signals you're looking for are probably hidden and less relevant within this data set. But when we query for specific items or specific keywords, right, then there will be a transition in significance. So in the subset, you will receive the things which were hidden and less relevant. They are now become more relevant actually in the subset, and that's all about with the significant terms aggregation. Sorry for that. I didn't want actually to watch that now. So let me show you how that works with just giving you some of the examples. And here is a credit card fraud detection with significant terms. And you see that we just imagine a customer or customers calling a bank and telling, hey, I see that there were some payments which I didn't do. So help me to resolve. What bank will usually do, there will be analysis to find a common point of compromise. And the way how you can do that, and that's not that easy, right? But the way how you can do that is by combining, like in this query, by combining the credit cards which were hit by these fraudulent activities and applying the significant terms, which basically means that we are shifting, because in all transactions of the bank, when you look, most of the transactions are okay, they're good, and some are actually fraudulent, right? When you just run a terms aggregation, then you will get a mix of probably more good, legitimate transactions, and just few which are fraudulent. And that's a problem. With significant terms, you change the game where the popularity, or not popularity, but significance shifts towards fraudulent activities. That's the way, and this is the aggregation type and the way how you could do that. Now, another example, and there is actually a blog post when you want to read a little bit more details and see the queries in detail, and code behind that. So when you look at the this cartoon picture, whenever you deal with analysis of data, right, you have mostly results which will be very much aligned with the population. Like you see on the left top side, population of United States. If you ask the question like, okay, who are the subscribers to Martha Stewart living, then you will see pretty much the same map, right? And that's because this tends to be towards top locations, right? We can change that. We can change it by using the significant terms aggregation. And this is an example from UK crime data, basically, right, from around Stanford. So by applying the significant terms aggregation, you will be seeing an unusual place for unusual crime types, and that's actually around Stanford, as I said. And there is one specific crime type, like carrying a weapon, and it's because some passengers, or many passengers, trying to bring a weapon to the aircraft. Right, so this is a kind of this will be hidden in the bigger data set, but again, due to the significant terms, there is the transition of the significance, and that's how you catch up with this type of signals. Another one is root cause analysis of car failures, and that's again from UK, where car damages and car when cars fail or broke on the road, then there will be I think police they're taking a report, right, and there might be some structured data, but the report also contains a textual field where police officer or whoever is taking report can just describe what is broken, right? So it's really textual information. Now with the significant terms, we can actually kind of find out what are the significant terms, kind of the cause, actually the reason for the failure. In this case, it's coil spring for a specific brand. And again, that's not easy otherwise to extract this data out of a textual information, textual data. Now, again, you have the ability, or do you have the link to go and read a little bit more in detail about significant terms aggregations? There are a couple of more things you could do with that, like training classifiers, categorization, or revealing bad categorization of content, and that kind of thing. So it's really highly recommended, because that even though it's not immediately related to entity-centric approach, it helps when it's investigated to investigate the data. Another aspect I want to cover here is, based on significant terms, there is ability actually to put things in relation by using graph search, and that's a capability we have within Elasticsearch itself, again with query capability and significant terms, but also on the visual side in Kibana itself, and that's something I want to show you too. And I want to use this example published in the Wired magazine. There is quite interesting posting I came across where somebody said, well, this person wanted to book a Airbnb, but yet he booked the Airbnb place, and then when he was in the room, it appeared to him that the room looked differently than advertised on the listing, right? So he started to investigate a little bit more about what's going on here, and he found out that there is actually a lot of fraudulent, like fake listings going on. So people create different accounts and advertise, use the same pictures, partly description to advertise rooms. So that's kind of interesting story, and we want to see here how we can leverage significant terms and graph search actually in Elasticsearch to detect that. So what I'm going to do here is to show you a demo, and this demo is based on Airbnb data. So it's here the link. I provide a link. You can actually start downloading this data and working with it, try to mess around a bit. Now let me switch to the demo itself. Sorry, that's the exactly that's the demo. So what you see here basically are listings for over the world for a certain period of time. I don't recall exactly what the period of time that is, but I think that serves the purpose for this demo. And what you see here is Kibana again, just a dashboard. We kind of visualize and give you an idea what this data is about. So we have obviously geospatial information because we know where the listing or place to rent is, maybe London, Munich, and so on and so on. We have some other data here, like we obviously can work with price information. We have room type, we have sentiment, and that's, by the way, something we like here. You see sentiment, something you can use to enrich the data. And see here, you see quite clearly that we have a change in numbers, obviously in bookings and or as comments. That's because of COVID. You see, it's around the beginning of 2020. So we have reviewers. Obviously, we have names of the reviewers. Just for this specific example, I want to say that the names here are not unique. So we're using for further analysis unique IDs. That's why you see here like a lot of reviews by David, Michael, and that kind of thing. This doesn't mean that's one person. It's just the person is called David. So you probably can hear interesting study about most popular names in this space, right? And then we have reviews, obviously, which we enriched as well with language. That's something because I'm going to cover machine learning and detections. Like in this case, we did language detection and enrich the data accordingly, so which might be important. And here is another one just to make my point is image check. So it's basically hash values, pre-calculated hash value about rooms, and that way you can detect similar or the same pictures used in different listings. Now that's the data we have, and what I want to show you how you can use this data actually to build relationships using graph. And we start with this view. Give me a second. So again, graph is based on significant terms, and the way how it works, you see that we hopefully you can see that, but let me make that enlarge it a bit. Okay, so what we see here, for instance, is the name of the reviewer, who is David, and David has been obviously very, very active providing reviews to different people. Again, here we're using, as far as I know, names, not the unique IDs, but so at the end of the day, it might be even more people whom he provided a review. So that might be a little bit anomalous. We don't know exactly. Probably that someone who travels a lot and books a lot of places, that might be legitimate, but still interesting to look. Might be suspicious. This is just all the way around where a host name has been receiving a lot of reviews, right? Which might be okay as well, because when it's popular placed and people like that, they probably will leave a review. And this one is interesting as well, and probably a little bit fraudulent. That's something we, as analysts, I will spend time here to investigate. You see that we have a bunch of people who are reviewing, a bunch of people who are hosts, and somehow they're really strongly interconnected. Right? So let's have a look what we can do here. So let me mark all these hosts, reviewers, sorry, and visualize that in Kibana and see if we can see here anything interesting. All right, so again, this is filtered, and you remember I talked about the queries and keywords and filters and aggregation. That's exactly where it kicks in, right? So we can again interconnect the graph view based on the same data to dashboard, and that's the nice thing about when you when you do this entity-centric approach and enrichment of data, then you can use both ways. You have enriched data to use both means. Now, what you see here, obviously, is that there is one person that's interesting, Anna, and again, behind that, there might be many different persons as well. She has been, or they have been really very active in terms of giving positive but negative feedback, as a both. At the same time, you see that the different account IDs behind the name Anna are like 600, around about 700 accounts, which might be okay. So like that many people give the feedback. So it's not one person living reviews. That seems to be really quite okay. Again, this is just a little explanation how analyst workflow might look like in Kibana. Let me go back to graph and show you a bit more about how we can attach additional information like risk scores to the data and relate that in a graph or in dashboard. But first of all, let me switch to quickly to presentation, and I will show you what we did in this specific example. So we have calculated risk indicators, and there are some which are critical, some are less critical. For instance, when someone is using same pictures, same images for different listings, that might be quite critical. Might be an indication that someone is using using fake listings. Not necessarily, but it can happen, right? Or another one is someone is reviewing multiple, multiple times, the same house multiple times, right? So that's the pre. You can use actually something like additional ways and tooling in Elastic to run these computations and attach these results to your data. Now, what I want to show you here is how that looks like. And now we have a pretty empty graph, but we can run a query here because we're a search engine, and I want actually to find everything which is related to images. In a second. All right. So here is a graph, and what you see here is that there is a host ID, and with this host ID, obviously we have different listings with different IDs. What's interesting about these listings here, that they obviously use the same images, and again, it's based that we calculated it outside of Elasticsearch, right? So use like Python or whatever you want to use and compute hashes, and that's something with this data you can put into Elastic and make it searchable again, right? So you see that this entity was enriched by this additional information. Again, that might be legitimate when you have a house with different apartments within the house, and they all look the same, right? So you will be using different listings possibly, right, with the same images. But again, in some situations, it's not okay, and that's something you want to investigate. Now let me go back and see and show you a bit how that would look like with this risk scoring in kind of fully blown fashion. The video stream is slowing down my performance here, so my apologies for that. Now you see that might be an interesting example, that you see a host ID again, which is being associated with many different listings, right? And then we see that these listings are associated with some risks, like images, same images, same reviewer, for instance, right? And that way you can again build your data structure around that and start visualizing using dashboarding or graph. Again, sometimes it's not really easy to see that, like just by dashboarding. That's why you need to see a different visualization, like graph, for instance. Right? Now, let me move on and talk a bit about named entities. I think that's another important part, specifically, again, when you deal with textual information with no obvious structure. And one example which I can give you that's interesting, one of our users talked about how they use, because banking space is highly regulated and they need to make sure that things stay within compliance framework. They have this e-communication surveillance, and there is a really interesting link which they delivered a couple of years ago, but I think it's still very, very interesting even for today's times. So I highly recommend to watch this. Now, what's the problem? And the problem is when you deal with textual information, then you have something like this. So you have this text where multiple different people or things are mentioned. Like obviously there is a person, Andrew Wilkie, and there is a party, a name of the party mentioned, it's labor. Then we have date, obviously we have some other people, and so on and so on. So the question would be like how we make sure that we extract things or people, so that we can ask questions about people and probably nearby things, or vice versa. So for that, we will need to get access or to use something like Spacy or OpenLP, basis technology. That's a combination of open source and commercial tools. But again, these tools are specialized to extract the meaning. One thing, however, is where it gets frustrated when you think about the extraction itself. Okay, we have now information about that it's a person, and think about, for instance, a article where John F. Kennedy is mentioned and Elvis Presley. That might be a really, really interesting article, or blog post, or newspaper article. But what happens when you start searching for that, and instead of John F. Kennedy, JFK is used, so the abbreviation, right? So you're going to have really hard time to figure out, or to create a more or less complex query to make sure that you can catch up with all variations of spelling. And so the question is how we can deal with that. And that's where it gets a little bit more technical now. Elastic has been providing, quite interesting way to annotate extracted data. It's called annotated text. And there is a way where you can, actually, like in this example, where we extract the name of the company, for instance, right? And annotate that with taxonomy, like it's obviously it's a company, right? And there is a date. And the way how you could do that, and what you see here, by the way, is a query, analyze query. There is a way in Elasticsearch to try out things before they get indexed, right? And this analyze API helps you with that. So if you want to understand how this annotation look like, then you can, go to Kibana. There is a dev tool area where you can, just provide a query, DSL, basically a query, and then run this query and see how the system is going to analyze that. So annotated text helped with that a lot of time, and the way how you can basically do that. So you potentially, or what you gain with that is potentially that you can ask questions about something about. Okay, I could ask like, hey, show me the JF Kennedy, all related information about him. But when you want to know about all presidents, then you probably will need to use, again, this annotation, because you will ask the question, okay, show me all information related to presidents, right? And that's exactly the type of things we actually want to see. Now, when you get started to work with, when you want to try out and take it for a spin, there is actually a very good way to do that. Wikipedia has been providing something which is called DBpedia. And this is basically ontology, right? So when you search for John F. Kennedy, for instance, you will be receiving this type of ontology tree, describing that, things, living things, people, office holder, and that kind of things, right? So that's something you could actually leverage to make sure that you have access to the ontology, and then use ontology to annotate text. Again, now you could actually do interesting queries like, and the span here, that's as a query, which is not very well known, but it's a very powerful one. The reason probably why it's not very well known, because there is no representation in Kibana for this query, so you will need to come up with a query DSL, basically JSON notation. And what you could do with this query, you could actually ask questions about, show me someone near a thing. Like in this case, show me photograph of all office holders, for instance. You don't need to mention all presidents, right? And that way, create a more complex query, but you can just really ask this question. And that becomes really, really powerful for your investigations. Here's another example of using annotated text. As you remember, there were and still going on, but a few months ago there were a lot of information going on about Hong Kong and in China. You see this relationship here, right? And more suddenly, another signal appeared on the radar where London was mentioned, because there was a kind of crime happening in London. And this is the power of nearby query, right? So you can basically build this type of relationship. One thing I want to show you, and again, this goes into the area of using machine learning, artificial intelligence, and then results calculated by machine learning to enrich data you have, like the entities. And there are multiple ways to use machine learning. So Elastic has been quite progressive in terms of providing ready-to-go machine learning jobs and predefined jobs, and the way how you can configure your own jobs in the space of unsupervised machine learning. For instance, when you deal with time series data, log data, and that kind of things, we provide predefined jobs, or the way how you can easily define that without being a data science. There is also another way how you can do that, and that's basically by building your own models, right? And so that's the supervised area, and you can do that within Elasticstack itself, and that's something I'm going to show you. Or bring your own, portable models which you can load and then use for your investigations or enrichment of data. Just really. Covering a little bit about unsupervised machine learning. I'm going to cover the supervised in a few minutes. Use an example, but here you can use transaction volume. For instance, in the banking environments, you probably use not only textual data, but you might also use some timestamp data with some numeric values, and you probably want to attach that to the entity, right? So there is a way how you can run analysis on top of that using machine learning, like really volume or population analysis, rare occurrences of something, or behavioral analysis. That's built-in functionality we have in Elastic itself. And what I want you to show you now is how you can basically configure outliers, outlier detection in Elastic, and use this data basically to enrich your entities, right? Let me switch to another demo. So what you see here is, again, Kibana. So Kibana is not, for everybody of you who is new, Kibana is not only to build dashboards, but again, there are the solutions I talked about, and also a way to do other things like configuring machine learning and using machine learning. What you see here is the data frame analytics, and that's where you can configure jobs, like outlier jobs, for instance. We see that we have some jobs running already deployed, and again, I'm going to cover a couple of them, or one of them. I want to show you how to get started with as example, outlier job. And first step, we'll need to define what data you want to work with. And for this purpose, I'm going to use demo Airbnb New York City. So then you can decide if you want to use outlier detection, aggregation, classification. I want outlier detection because I want to see if there are any kind of score outliers within my data set. And what I'm going to do here, I will switch to the JSON editor, because that's a bit more compact in terms of what type of settings you can provide. So first of all, let me give it a name. outliers. So second, we need to provide, obviously we selected the index. It might be one index or multiple indices. That's the flexibility you have built in Elasticsearch. Now, what we need to provide is fields we want to analyze, and obviously we're interested, or I'm interested in price outliers and number of bedrooms. So that's the fields where we're going to use for detection. So index name must not be empty. Let me take the index name, because and that's the good thing about Elastic. I forgot to mention is that when you run these jobs, machine learning jobs like outlier detection or something different, then the data will be written into a separate index, and you can use this data actually for visualization or further processing of this data or enrichment of the data for your entities, for instance, right? So all these results will be written in one index. That's why it's asking about destination index. So we can start immediately, and the data set is not as big, so it will take just a few minutes to compute that. So let me go back to the result set. So it's reindexing and calculating the outliers. By the way, we have a good documentation in terms of what algorithms we're using in terms of outlier detection. So so have a look at the documentation on the website. It's still computing, but I have fortunate enough, I have another example which is already done. It's New York City. Here we go. We can look into that. And what you're going to see here basically is some statistics about the job. You can see the again the configuration of this job message, and that kind of things. But more importantly, you can actually start looking into the tabular view of and understand the outliers, right? So the results which are written in a separate index. All right. So what you see here, and let me actually change the columns we were looking at. So we want outlier score, obviously. I don't know if you see that, but let me make sure that it has better visibility. A moment, just a sec. Okay. So we want outlier score, obviously. We don't need timestamp. We don't need access. We don't need access keyword. Accommodates a number of people. We want to have that. We don't need amenities, availability for the days. What I want to have here is as well price. So let us search for price. Here we go. That's the field we want to have. We want to have a name of the place. We want to have number of bedrooms. So I think that's enough. So what you see here, okay, let me remove availability. So what you see here basically are outliers, and the color, the background color here indicates how influential these specific values were. Like you see this listing that it has been providing 21 rooms, 21 bedrooms, which might be an anomaly, because if you look at it only accommodates two people. That might be just a mistake, right, in the listing itself, right? But then you see that some other listings were influenced by the price point and that kind of things. Now, what you can do, you can use this data to enrich again your entities and attach, for instance, scoring, like outlier score to the entity and visualize it in a graph. But what you also could do is use that in dashboarding, and that's something we're going to see and connect that with other data like the geospatial information, for instance. So we have our outlier dashboard here, which shows, and again, we filtered here for New York City, right? So it shows only outliers in New York City. Give me a sec. Here we go. So you saw this table, and it's again the same data we saw in the outlier detection or calculation. We can use that in here. More interestingly, actually, again, if you look at here, all listings available in New York City, that's something probably we don't want to see. So we can use this data now to the data we calculated, the outlier detection, to limit specific to specific listings, and we're interested in listings which have outlier score more than 0.9. So let's see what we get. Bear with me, it's a little bit slow because the streaming consumes a bit more power than I expected, but I think we should be good in a few seconds. And there might be also a lot of load right now on the demo system. All right, so we see a quite different picture now, right? So we can start analyzing that in different ways, right? So we can, we're looking now at all apartments which are quite heavily in terms of outliers. You see that this one might be because it accommodates 25 people with 7 bedrooms and the price point. So we need to look into what exactly was influencing this detection, right? But that way you can do that, and again, you can start investigating into, okay, let's say we want remove we want all all listings which are probably less than 400 US dollar. Here we go. All right. So this is again an example. And coming back to the presentation, this is an example how you can use multiple things in Elasticsearch to work with data, to enrich the data, to annotate. So I hope you enjoyed the session. If you have questions, again, there is a way to ask the question. I will try to answer them here immediately. But please reach out to me if you want to have a private conversation. Right? So that's something we can accommodate as well, and I can direct you to additional resources or help you with your specific questions. So let me see if is there anything. It seems to be.
Thank you so much, Dimitri. It doesn't look like we have any questions at this time, but we can give it a few seconds and just see if any come in. If you do have any questions, please feel free to put those in the YouTube chat now. I did share a link to our reactor survey. If you do have a few minutes to fill that out, we really appreciate the feedback. We want to make sure we're delivering sessions that our community is excited about. We have the link in there, and then there's the event ID is 15229. That will be the first question they are asked when you fill out the form. That just helps us connect the survey back to this event. So again, that event ID is 15229. Yeah, it doesn't look like we have any questions right now. So thank you so much, Dimitri. Really appreciate this, and hopefully we can have you back again soon.
Thank you, everyone. Thank you for organizing that and attending the call. See you next.
Perfect. Thank you so much. Bye, everyone.